Hello and welcome to STEM with Mr. N, where I perform different demonstrations and explain the science behind what we're seeing. Next week, on Wednesday the 29th, it is Chinese New Year, so I've taken some inspiration from China for some of the activities I'm going to show you today, as I have fun with friction. Let's check it out. Friction is a force that exists between two objects as they move or slide against each other. If you were pushing a book across a carpet, for example, you would feel friction slowing down the progress of the book. Friction is also a force which works in the opposite direction of the movement. So if you were pushing the book to the right, the friction that you'd be receiving from the carpet would be pushing back to the left. Friction can slow down and completely stop things from moving, but friction is also what allows us to walk along the ground. When there is less friction, like when you're walking on ice, you slip and slide. The first activity I'm going to look at today explores the friction that is encountered across different surfaces to see which one has the least friction and which one has the most friction. For this, I'm going to be using a tray, a penny, and I have some different materials for sliding the penny down, such as the back of the tray, a poly pocket, a laminate sheet, some cardboard, and some polystyrene. I'm also going to be using a ruler for this to bring in some maths and to try and make it a bit more of an accurate experiment to see at what height I need to lift the tray to before the penny starts sliding down it. I'm going to start with just the surface of my tray for testing to begin with, and I'm going to hold my ruler upright next to the tray to measure the height that I'm lifting the tray to. I'm going to place the penny at the top end of the tray and then gradually lift the tray until the penny slides down it and see how high up on my ruler I had to lift the tray. So at about 16 centimetres the penny slid down the tray. Now I'm going to put a bit of cloth at the top of the tray, put the penny on it and repeat the experiment and see how high I need to lift it now for the penny to slide down. That time I had to lift the tray up to about 29 centimetres, so the cloth is producing a lot more friction against that coin, stopping it from being able to move until that height. Next, I'm going to try with the penny on top of a polystyrene sheet. So that time the tray got up to about 29.5 centimetres, so the polystyrene is producing friction roughly the same level as the piece of cloth that I tried just before it. Now I'm going to test with a laminator sheet. That time the coin started to slide around 16 centimetres, so the laminator sheet has about the same amount of friction as the tray against the coin, and so far the tray and the laminator sheet are allowing the coin to slide earliest, which means they have the least amount of friction, but there's still two more things I'm going to test. Now I'm going to test the poly pocket. The tray got up to about 17 centimetres there, so the poly pocket has slightly more friction than the laminator sheet, and I actually thought that would be the case because the poly pocket sheet feels rough whereas the laminating sheet feels smooth. And finally, I'm going to test my piece of cardboard. That time the tray only got up to about 15.5 centimetres, which I was quite surprised about because I thought the penny would have been slower on the cardboard. However, it turns out the cardboard has actually been the fastest one out of all of the materials I have tested. This has been a fair test because I have not moved the ruler from its position, I've used the same tray, the same penny, I've had the penny facing the same way on every experiment, and I've lifted the tray slowly for all of them. So it has been fair, and the cardboard seems to be producing the least amount of friction against this penny. Next I'm going to show you an incredible experiment inspired by the upcoming Chinese New Year. Being married to a Chinese woman means that Chinese New Year is something that we celebrate in this household. Red is a very lucky colour in Chinese culture and especially around New Year, which is why I'm wearing my red polo shirt. Now, as I'm sure you'll be aware, rice is a key part of the Chinese diet, and being married to a Chinese woman means that we always have lots of rice in the house. I'm not going to be cooking rice for today's experiment, but I'm going to show you how I can lift a full bottle of rice using only a chopstick. To do this, I'm going to start filling up an empty bottle with rice. Some rice is falling round about the table, so you might want to use a funnel if you're trying this at home, or just be prepared to have to sweep up some rice. Once I've got the bottle filled all the way to the top, I'm then going to push my chopstick down inside the rice, You'll notice I'm going with the narrow end of the chopstick and pushing that down in first, but you could do it with the opposite end. It doesn't make a difference to how this experiment works. Once my chopstick is pushed in, I'm going to press down on the rice at the top of the bottle and top the bottle up with a little bit more rice and then press down on that. Now that I've filled up my bottle with rice and put the chopstick in, watch what happens when I try and lift this bottle by holding only the chopstick. You'll notice that the entire bottle of rice comes up when I am lifting it just using the chopstick. And even though this bottle is full of rice and is heavy, it is not falling down. So why am I able to lift this bottle of rice just by lifting the chopstick? This is because, as we said earlier, friction is a force between two objects rubbing together and it works in the opposite direction. When I put the rice in and pressed it down, I forced the rice to fill all available space that might be taken up by air, so there are thousands of grains of rice pressing against this chopstick. When I try and lift the bottle holding only the chopstick, there are thousands of grains of rice pulling in the opposite direction due to the friction between the rice and the chopstick. And that is why I'm able to lift it straight out. If I want to get the chopstick out of the bottle, I could either shake the bottle up and down and it will fall, or I could just take hold of the bottle and pull the chopstick out. And the force of me holding the bottle and pulling the chopstick overcomes that friction between these two objects. The history of paper traces its way back to ancient China, and I explored this more in my video last year about how to make your own edible rice paper, so I'll put a link in the description for you to check that out. But I am using this history of China with paper and two books by the Chinese author Cixin Liu to show you another cool friction experiment. Now, if I was just to take these two books, open them up about halfway and slot one book inside the other, and then try and pull them apart, they both easily slide away from each other. There's not a lot of friction being created there. So I'm going to do something different with these books. What I'm going to do is put down the back cover of each book with one book's back cover overlapping the back cover of the other. And then I'm going to start working through the book, overlapping pages, one from each book at a time, gradually working my way through the book. You don't have to fold together a lot of the book. As you'll notice, I've not even gone halfway through either of these books. I think I've only done about 100 pages from each book. But now when I try and pull these books apart, I can't do it. I cannot pull these books sideways to separate them. And that is because of all of the points of friction that I have created. Every one of the pages that I've folded in to touch one of the pages from the other book is creating a point of friction. And by folding in 100 pages from each book, there are now hundreds of points of friction in this, so I physically cannot pull these two books apart. This is a great one to try at home. You don't need a big thick book like this. As I said, I've not folded together lots of pages from each book. You could also try doing this with something like post-it notes, just as long as your sheets of paper that you're folding into each other are attached in book style, so it's like you're joining two books together. So you can test out lots of different things to see how you can get them to stop moving using friction. The only way for me now to get these two books separated is just to bend them out and let the pages slide out from each other. Well, that's all for this week. I hope you enjoyed it. If you're somebody that's celebrating Chinese New Year next week, Gong Hei Fat Choi. If you liked this video, please hit the like and subscribe buttons to stay up to date on all future content. As always, I would like to take this opportunity to answer any science questions you have about any science topics at all. So feel free to email me at stemwithmrn@outlook.com and I'll get back to you with answers to your questions. You can subscribe to the channel by pushing the button here, and I've added links here to the other STEM demo and explanation videos I do, here to my 10 things you should know about series, and here to my series on 100 scientists who influenced the world. This has been STEM with Mr. N, having fun with friction.